Good afternoon, everybody. My name is Tomasz Janicki, and together with Marcin Płocki and Tobiasz Mróz, we have a pleasure to welcome you on first Nanotech Day webinar. At the beginning, I have to mention that the webinar will be recorded, and we will share the file with you after the together with the presentation after the webinar. If you have any question, please do not hesitate to ask us using the chat. We will try to promptly answer during the webinar. Let's take a look at the agenda of the webinar. In the first part, Marcin Płocki, Chef of Business Development, will present how the BMS solution has been evolving since last 20 years and what ISMA controlling try to do to support latest technology trends. Then I will explain you what the nano edge engine is and what kind of benefits you can bring to your BMS system. And after that, Tobiasz, the technical training specialist, will guide you with the live presentation. At the end, you have the unique chance to see the live video of the future functionalities. So Marcin, please start with the presentation.
Okay, thank you. Welcome, everyone. Thank you for joining our webinar, which is first one. I hope there will be more in the future. Today, my job is to try to answer the question why we developed nano edge engine. I hope I can give you the clear answer. But before we go to that question and answer, I would like to touch and talk to you about history of our industry, how the BMS industry has evolved over the past few decades. I hope there are still with us people which remember the very early system where we had very simple controllers, a lot of hardware interlocks, no communication, no software, and that was the very first stage of automation in the buildings. Later on, we had the opportunity to develop the more communications, and those communication allows exchange of data between the devices, exchange of data between the devices and the software. So that was when the early BMS has arrived. Because of more and more BMS implementation system in our industry, there was as well the possibility of the technology called dial-up to use it in our industry. And that was the first time where we could say the remote BMS has arrived. That was the time where instead of just seeing the data and manage some settings, set points, and so on the building, we could access the building remotely by using the dial-up technology. During that period of time, a lot of new communication protocol has been developed by different manufacturers, and that actually became a little problem at the very beginning of 19th. And the help arrived together with the Niagara. Niagara framework from the day zero was a platform dedicated to allow the integration, the device in the building. And that was a huge impact for our industry. That was the time when the integrated BMS has born. This piece of software and platform allows us to exchange the data not only with the same system, but as well with other subsystems. And that allows us a big transformation in our industry. Together with Niagara, at the latest 19th and beginning of 2000, the web technology as well has become more and more popular. And Niagara from day one was designed to utilize this technology. And that as well helped us to build and deliver not only integrated BMS system, but as well web-enabled BMS system, which means instead of using a dedicated piece of software to monitor the processes inside the building, we could use standard web browser remotely using the IP connectivity and access to the system with the simple web browser. And this is a very short history. Of course, we could spend more time on this, but today is about more future than the past. So where we are today. Today, this is the example of today architecture of the standard BMS system. As you can see, in this architecture, we still have a lot of RS-5 devices, like Vincol units, panels, actuators, which some of them they are network actuators, some of them they are hardwired actuators. We do have an IP layout where there are devices like network controllers or integration controllers, gateways, DDC controllers. All those devices, they exchange data between each other, either using the open protocols like Modbus, PACnet, LON as well, or some other closed protocols. On the top of that, in many cases, we have a BMS software, which is installed somewhere on the BMS PC. And that software is to allows the visualization, access the data to all those devices, collect the data, generate the alarms. And in more advanced buildings, we do have as well the even higher level, which is a cloud. But before the data go to the cloud, in many cases, those data from the controllers, they are not ready to be shared direct. So the BMS software, one of the role of BMS software is to prepare the data to cloud. And that's done through either tagging the data or as well transform the well-known protocol in the building into the more known protocols for cloud and IT systems like MQTT, Haystack, and other protocols. And once those data, they go to the cloud, then in the cloud, there are more advanced things happening, like we do have data analytics at the cloud, we do have AI, machine learning, and this is quite complex architecture, but allows us today to do a lot of nice things. But of course, apart of those nice things, we still got some problems. The main problems with the today BMS architecture is the time, and as we all know, time equals money as well. So because of such a complexity of the architecture, and because of the technology of the devices using on the building, a lot of simple and a lot of time-consuming activities, they still need to be done in the building. So, for example, commissioning, programming have to be done in the building. And that's not cheap process and as well time-consuming process. And this is one of the reasons we sit down in the team with this microcontroller and say, okay, why not to change this? Why we cannot eliminate all those problems and make our life easier? But to be able to eliminate those problems, we should allow devices not only be part of the IP network, but as well be able to communicate, ready for IoT, and talk direct to the cloud system. And if we could do that, and the devices could as well be fully programmable remotely in a real life, then the people which are commissioning guy, programming guy, they don't have to be anymore in the building. They could stay in the offices and remotely do a lot of work, which saves a lot of time and money. And we believe after the research as well, we did it, and after a lot of discussion we had with our customers, existing and potential customers, we believe that in the very early future, this is something which is already happening. More and more devices, not only the devices which are devices based on microprocessors, those devices that are very advanced, powerful devices that are basically, in many cases, a PC with Linux, which in our case, they are powered by Niagara. Not only those devices, they're going to be able to be part of the IP and connect direct to the cloud. But as well, we believe that other very small devices, which are based on microcontrollers, devices such actuators, VAVs, room application controllers, or DDC, and maybe sensor in the future, those devices, they should be allowed to be direct part of the IP network, and they should be able, in a secure way, talk to cloud. And if those devices, they can be as well real-time programming, you can imagine how much we can utilize cloud having such an infrastructure. Because in the cloud, there will be not anymore just a data collection, AI or machine learning, but as well, we can take commissioning process, programming, servicing, adaptation of the application into the environment to the cloud level. If we do that, and if we as well develop something, some simple user interface for users like administrator, engineer, or end user, which they're gonna be able to talk to cloud, and through the cloud talk direct to those devices in the building using simple interface, then we could change our industry, and we could eliminate the problems linked to the time and money, of course. And this is what microcontroller is doing. microcontroller has developed the nano edge engine, which is a platform, allows transform those simple devices to become a smart devices ready for IoT connectivity, fully managed from clouds. We as well develop the first release of IC Connect, which will allow us in the future our users, I mean the engineers, administrators, and end user, to use the power of cloud and nano edge engine using the simple interface IC Connect. But this is something we're gonna discuss not at this webinar. This is another topic we're gonna have probably very soon. At this stage, please focus on nano edge engine. And I think I answered the question why we developed this nano edge engine, because we believe the future is coming and is already happening. And that's the reason we developed a platform for microcontrollers to allow simple local devices take part of the IoT connectivity and make them smart. Thank you very much. Now, I would like to ask Tomasz and Tobias to show what the nano edge engine is all about it, because this is just a presentation, but we want to take you to this adventure and show in a real life what can be done with nano, which device is already using nano, and what is the future of nano coming soon. Thank you very much.
Thank you, Martin, for the deep explanation, answer the question why we should use nano edge engine. But before we start the technical part, I think it's worth to know what the name does exactly mean. So nano, it means it's extremely light software designed to be installed on edge devices based on microcontrollers. Like you said on previous slide, it can be actuator, controller, sensors, maybe I/O modules. Edge, because it's tailored to provide those edge devices intelligent and smart functionalities. And engine, because it allows us to build logic, integrate the other devices, collate and expose data, and connect the devices, those data, with the cloud. And it's developed to be hardware independent. The nano edge engine is built in a modular way with clear and logical structure. Architecture is divided into 4 containers, and those containers will be deeply described today during the technical session. Nowadays, nano edge engine is powering a room application controller, RAC18IP, and this controller is used to show all the functionality during the technical part. What is really unique? Here you have some key features which will be shown today. So Tobias, please present them using the real device.
Okay, so I'm just going to share my screen and I'm going to show you what exactly the guys were talking about. I think this was a great introduction into what I'm going to show you. So having learned about the history, about the basics of the nano edge engine and the most important features, now we can go straight into the technical part. So what we are going to do, actually, we are going to work with the RAC18. So this is what I'm actually connected to. So in the left-hand side, you can see a device that I'm connected to. here I have my IP address. Okay, so Tomasz mentioned about the 4 containers, which he mentioned that this is a core, this is the most important part. This is a crucial thing, so I'm going to just explain each of them in just very few words. So each of them plays a little different part in our system. So each one have a different responsibilities, different purposes, and also different limitations. So probably it's good to know what you should do in each place. So the application, which we have first, the first child component, the applications is like a heart of our system. This is basically where all the crucial parts of our program are going to happen. So when you think about creating logic, building blocks together, linking them, creating algorithms and stuff like that, it's all going to be happening here. And this is the only one of those 4 containers that is executed in cycles. So cycle means that every component inside is executed in a fixed time. And I'm going to touch upon this a little bit later on in a deeper explanation. Next up, we have networks. So this is a place where communication happens. This is like a communication center of our device. If we try to reach any other device, any other system, whether we're using BACnet or Modbus, this is a place to go. So every time, as a client, we want to get data from other devices or systems, this is where we are going to do it. Then we have services. This is like an additional utility center of the device. So any other communication that is not taken care of in the networks will probably be able to be utilized here. And what I mean by that, probably the most natural example would be like a weather service, which you can take some additional data from, or system which have APIs on the internet, which you can connect to and exchange the data. And last but not least, we have a system component, which allows us to basically control how the hardware is performing and what are the settings. So this is like a commanding center where you set the IP address of the controller, some time preferences, Ethernet, DNS, so you can set those as well. This is also the place where you can create a backup of your application to be sure that you have the latest version of your app. And also you can probably, if at any time you face some troubles during your communication or programming experience, you can go to the logs, you can troubleshoot some issues. And yeah, this is the place for those kind of things. Okay, so just short few words about each of the containers. Now we can start doing some stuff. So before doing any work, actually, it's good to know what tools we have in hand. So to do that, let's go into the root element here in the left side and go to the software manager. So this is a place where we manage what libraries we are using. So this is what we are going, this is what you see. These are the libraries which are inside our controller. So as you can see, the nano engine is structured in a modular way. So each like a function is taken care of by a singular module. And as a default, we have those 7, as you can see. We have operating systems and libraries which are associated with the operating system. So this is like a package, a default package. This is what you get when you first get your controller and then you start working. However, when you create your application, when you create your logic, when you create your networks and stuff, additional stuff, you may need some additional libraries. So this is exactly what you are going to do. You can pick some additional libraries and put them into the device. So in my case, I'm going to use some logic and process to help me build my application logic. And also I'm going to show you later on some additional features which are not yet released, which is going to be haystack, also tagging functionalities, and also web, which is going to be used to show you the graphic page. okay, after the selection, you can just update the device to make sure that those libraries are going to be sent to the controller. So it takes just a few moments. It doesn't take too long. So probably a few seconds. Controller is going to be disconnected, but we should be able to reconnect pretty swiftly. Yeah, and just like that, we are back up. So
I think it's worth to as well add that using a single connection, we can not only program the controller, but as well we can fully manage the controller. So this is one single connection through one single port,
yes,
which is quite important because in the case you have to expose the controller into the public network, there's only one port forwarding needs to be set up, and that allows you to fully manage the device.
yes, exactly. That's the case. So you can either program and also manage all the other hardware related settings or make a backup basically anywhere, anything that is related to the controller.
Yeah, update the operating system, add module, remove the module, and so on, so on. So I think this is quite new probably to what we have today with the Niagara or Sedona the devices, but I think it's very important to remember. I think it's one more information is very important for all our audience that when we want to connect to the device, we don't have to have any modules or any operating system local on our machine. Basically, we don't have to have the copy of that to be able to talk to the device. All those information we are receiving during the connection process. So what it means if we don't have some module on local machine and we want to connect to the device which has got an extra library, which doesn't exist on RPC, it will still allow us to connect and fully work with this device.
Yes, exactly. That are good two words which Marcin added. So now having all of this and having know all of those things, let's go to the next thing, to the application. So in this live demonstration, I'm going to show you how we can utilize the new things that are allowed in applications container. So you can see it right away here in our starting screen, basically, that there is a multi-threading application. So for efficient resources management. So basically, we can create multiple applications, and those applications can have different cycle times. So let's say that I'm going to create a first application. So I'm clicking on the application, and from the code library, I'm taking a new application. So this first one, let's say, is going to be a lighting application. So the characteristic of the application that is controlling the lighting is that when you click on the button, you expect instant reaction of the system and instant result, which is switching on the light. That's why the scan period needs to be rather low to pick up those changes just on the fly. Because if you put the scan period, let's say, to 1 or 2 seconds, after clicking on the button, you have to wait a few seconds, and then there is a slight delay, which in the case of a user experience is not probably something we want to have, because this will feel off, to be honest. So for the lighting, we keep it low. However, you may think, okay, I'm going to create a second application. And the second application is going to control some HVAC things. It can be, for example, a room control application where we control the space temperature in some hotel room, let's say. So this application, on the other hand, is much more slower. It's slower. It is slow changing process, so we don't have to be so pressed for time. So we don't have to keep the scan period so low. So we can change it here. And let's say set it to 1 second, which is 1000 milliseconds. So this way you can distinguish applications based on their scan period. This way you can manage the resources of your controller, basically. So
how low we can go with the scan period?
Tomasz?
50?
50 milliseconds.
50 milliseconds. Yes.
Okay.
So you don't have to put everything into one container. You don't have to put everything into one place. You can just decide what kind of application it is and adjust the scan period accordingly. Of course, the 2 is not a limitation. You can have more. Of course, it's up to your preference and use case. Okay, then let's create some structure of my application. So normally, when you have your application, you may split it to, let's say, slower part, not slower, not larger, but smaller parts, of course, to smaller bits. So for that, we can use a folder in a classic way. Yeah, of course, this is a standard way that we could use in our other systems. However, we would recommend doing something different. Instead of using folder for that, I will delete the folder and I will create a new equipment. Okay, so I will structure my system using those equipments. So let's say I'm going to create a room control. And then we have 2 FCUs in this room control, FC1 application, and then we have parts of application for the FC1 and therefore the FCU2. So as you can see from the first outlook on this, you may say that, okay, there's no difference. I don't see any special changes. I don't see any special properties, which as of now, it would be true because there is no any special things. However, this equipment is going to be utilizing the haystack protocol and also the tagging functionalities. So we will have a much more functionalities which are going to be powered exactly by this equipment. So if you do it this way, then you will have much more other functionalities open to you. Of course, I will not show it, but later on, at the later stage of my presentation, I'm going to show you those future functionalities which are going to utilize those equipments. Okay, let's also create something here just for the sake of being organized. So in the lighting, I'm going to create a lighting zone. Okay, so now it would be good to fill the application with some data. And for that, we are using the data points. So if you right click here or here, you can add one of 3 data points: analog data point, binary data point, and multi-state data point. So let's add a new analog data point. Let's say that I want to have a set point for my application. So this is the first data point. And the second one would be, for example, space temperature. Okay, I'm going to just simply and swiftly and do the same for the second one. And the space temperature. Okay. So now we have those data points, which are used to model our application logic. So first of all, of course, just shortly, I'm going to speak about the details about the data point. But first, I would like to show you something about the creation of the logic and how the Nano Edge or maybe IC tool is going to help you with it. So let's say that we are going to create just a simple thermostat application. So for that, I would like to use a thermostat component. If you know where it is, you can just go into the correct library here, or you can just type it here, and it's going to filter for you the available components. Okay, so I have thermostat. I'm going to drop it into the wiresheet. Then I'm going to just connect the blocks together. And of course, I can set those values to some values which are resembling the real-time values. However, what I'd like to show you is something different. This is a really simple example because thermostat is quite straightforward. However, there are some blocks which are more sophisticated, have a lot of slots, which probably you may not know how they work just from looking at them. So in those cases, you probably would need to get some help. So it's really easy now because all you have to do is to right click on the component. And here you will say, you will see the show help button. So this basically redirects you to the correct space in our IC docs, which, you see the explanation, you see some graphical representation of how to link them together with other data points, and also the slots which together compose this block. So you don't have to worry about finding the correct space, finding the correct web page to look for the manual. All you have to do is to just right click and you're good to go.
Yes, I have a good question. Can we work together on this device, or is only one person allowed to work on this one, guys? I think it's a good question to raise.
It's a really good question. So we've got one network, so I can connect using the same IC tool, make some changes because it's the real-time programming device. So each changes is done immediately. Changes from my computer will be shown on Tobias' computer.
So what we see in this tool, if you go back to this tool, is actually what is inside the device. It's not offline programming, it's a real-time programming. They are connected to the device.
Yep.
Because there might be some audience with us which are not fully familiar with the real-time programming. So basically what we see here is coming from the device, and there could be more than one person working parallel at the same device.
Yes,
correct?
exactly. And they will all see the same. They will see the changes on the fly, so they don't have to upload, reload, or do any of those things.
Exactly. And we can forget about the compilation, the recompilation, decompilation of the code, because every change is being done automatically.
So basically any suffix or upper suffix with the compilation is not needed for you.
One more question, quick one.
Yep.
Do we have some save button here, or we have to save the application, or you're gonna talk about it later? No.
I'm not going to talk. It was not in plan, but it's good to have those questions. So Tomasz?
So no save button.
Yeah.
Changes are being saved automatically in the device. So once you have made the changes, it is saved in the device. So regarding the second question, you need to have the device connected. So we need to be online to make the programming and to make the changes.
Okay.
Okay, so let's go further. So I was doing the programming. So now let's talk a little bit about the things that are the main building blocks of our application, which are the data points. So first of all, I used to model the data. So on the right-hand side, you have some basic slots, basic information about them, like description, mode of the point, can be value, input or output. So this is like preparing for protocols, which I'm going to talk shortly. Also, you can apply units and stuff like that. So this is pretty basic. However, if we scroll down, we have two extensions. There is a backnet analog point and there is a Modbus analog point. So what it actually does in the background, it makes possible those points to be visible over those protocols. So actually, without doing any additional stuff, without doing any extra work, all I had to do is to create data point, just to right click and add a new data point. And this point is already visible over the backnet protocol and the Modbus as well, because this exposed slot is set to true. So basically, this is everything you need to do to see this data somewhere outside using some external tool, like, for example, Niagara. So this is exactly what I'm going to do. So this is my Niagara station, which I'm going to use to connect through the backnet protocol and through the Modbus TCP. So first of all, I'm going to use the backnet. So I'm going to discover the device. As you can see, without doing any additional stuff, I just started a default state controller. So I didn't create any network. I didn't configure any backnet settings. All I had to do is to just enable device, and it is already visible over the backnet. So now I can just take it to my database. I can go and discover the points. And as you can see, I have all those data points which I have created. Then I can fully integrate them and read them using the backnet. And the same goes for the Modbus. So if we take a look here, already this data point which we have here is configured in a correct way. So you don't have to worry about the addressing. This is error-proof mechanism, so addressing is taken care of for you. Here we have address 1, here we have address 0. We have also the correct register types and the data types. So
It's out of the box.
out of the box.
But we can change this because we have a special action called set ID and set address.
Yes, you can, of course, there's a gate for you if you want to have changes.
So basically, system will address and it will use the first available object or address, and then it will assign to the new data point. But if there is a requirement to change those addresses or object ID, we can always manually do it.
Yeah, that's the case, of course.
I think the key is that you don't have to create any Modbus register list or BACnet object list. The list is done automatically.
The intention as well from day zero, I mean, for nano changing was to develop a piece of software which as well allows those devices, they became a native Modbus and BACnet. So like you mentioned, Tobias, is you didn't do anything special to discover those devices over the BACnet and Modbus. So out of the box, when you power up the device with Nano Edge Engine, they are already going to be available, coming from the factory, they're going to be available on Modbus and BACnet IP network. So, and I think as well RS-5.
Yep. Yes.
But this is not, we're not going to show everything, but as well, we do support the exposition over RS-5.
There's a little configuration needed, however, still not too much steps to do. So let's also do the Modbus part. So we have address of our set point. Let's take it and go to the Modbus just to show you. So we have our points. The device is already added to save some crucial time. So we have here a holding register. That's why it's going to be numeric writable. There was a decimal format set. So it will be decimal, and here 0. I can set a name for set point. And just like that, of course, I can change it to see some value here, 26 maybe. And this value 26 now should be visible over Niagara as well. So as you can see, the change is resembled in both systems. And it is visible right out of the box.
And we support both at the IP level at the same time, basically, because it can be integrated into one system as a BACnet and maybe two other controllers share the data as a Modbus.
Yeah, so simultaneous connectivity is possible for sure. Okay, so now just a quick recap. We have applications. They are two working with different cycle times. One is faster, one is slower. Then I created the structure of my application using the equipments, and those are going to be powering some additional stuff later on. And then I filled my equipments with actual data using the data points, which not only are used to create application, but also to share the data at the same time. So we became basically a server of the data without doing any additional work. Okay, so let's wrap it up and now go to the networks. So I mentioned before, this is a communication center of the device. If you are thinking about the client connectivity, so client means that we, on the other hand, are going to take the data from some other exchange the data, and we are going to be requesting the data from some other devices on the network. And those networks can be BACnet or Modbus. Apart from them, we also have a local I/O. So this element is controlling how those 18 inputs and outputs are going to be used in our application. But the main part is going to be those two. So when we click on the BACnet and Modbus, we can see right away that there is some auto exposition slot. So in a simple words, this is just controlling how those data points are going to be shared. So as a default, if we have it to true, so it means that every data point that we create is going to be shared over the Modbus in that case. For the BACnet is the same. The auto exposition is set to true.
And the enabled slot is true.
Yeah.
If we make this false,
we can
this
disable.
device will be disabled as a Modbus or as a BACnet on the network.
Yeah. Of course, if you want to keep your privacy a little more strict, you can disable the auto exposition so that then you can decide on a point-to-point basis whether they should be available over the protocol or not. So this is, of course, flexible, and you can make those decisions later on. And inside we have some elements. We have basically device identifiers, which control how the device is seen by the others on the particular network. So we can assign the Modbus address, or we can assign things such as device ID for the botnet. In the interfaces, we control where those protocols are going to be utilized. So as default, we have Ethernet. So it means that we only have a botnet IP and Modbus TCP as a default. However, it doesn't stop us to do some additional work and create an RS-RAID 5 versions. So in this live demonstration, I would like to connect to touchpoint module, which is a touchpoint wall module, and this is a RS-RAID 5 device. So that's why it will not be possible to be reached over the Ethernet. So I need some additional component. That's why I need to go here to the Modbus, to the interfaces, and to the core library, inside of which I can take the serial port and drop it into the interfaces. Here I have some configuration settings I can do. However, in my case, this is what I'm going to use to communicate with my device. Of course, I need to still enable the serial port. The next step will be to go to the Modbus and create a new network. So now I'm going to enable this Modbus RTU network. On the right-hand side here, you have possibility to decide which type of network it will be, whether Ethernet, so it means that Modbus TCP, or serial port, which in our case is Modbus RTU, so over RS-RAID 5. And then, of course, enable the network. Okay, so we have network, and then we can go further down to create a new device. So I'm going to create a touchpoint device, TP. So for this, I need to just assign correct address, which in my case, because this is what I set on the rotary switch, is number 2, and set it enable swap to true. Okay, status is okay, so it means that I have communication. And I go one level deeper, and I would like to get some data. So I would like to read a set point, which I can manipulate on the buttons on the wall module. So for that, I will need to use the analog point. So I'll drop it here and use a set point. Set point. So of course, we need to know which address is used to store this data in this wall module. So the address will be 1500. Yep, so we have the set point, 300. However, of course, this is not the real value. We have to divide this by 10. And the scaling factor can be applied directly on the component. You don't have to use any additional mathematical elements. Here I can apply 0. Okay, and now it looks good. So now we have 30, and okay, so we have successfully integrated data point from the Modbus RTU device. So now it will be a good practice to good example to connect this data from the networks with my application that I created in the applications container. So let's go here and let's open the FC1. So the FC1 have those elements. So instead of using just manually, I'm going to fill it with real data. So I'll take the set point. This is how we would do it in a classic way. The source element, I need to go with the link mark. And on the destination, I'm going to choose the link from set point. Okay, so normally we would do the output and input selection. So we take the output of the source and connect it to the input of the target. Yep, so from the first look, we have everything working fine. Of course, you have value coming into the input. We have 30, we have status okay. Everything looks fine. However, let's do some manipulation. So let's say that I'm going to do some issue with the Modbus point. So instead of using correct address, I'm going to select 15,000 instead of 1500. So it's causing the point to go into status down. There is some communication issue, something is wrong. However, on our application, as you can see here, using the standard link, we still have output value of 30 and the status is okay. So we cannot see the actual value and status. So that would probably be a good thing to fix. And the second thing, let's say that I would like to change this point, not only from the wall module, but also from the BMS system. So from Niagara, let's say. So I go back to my Niagara. So this is the point which I previously added using Modbus TCP. Let's try to change it. Okay, 25. It looks okay. The value is 25. However, in my application, the value is still 30 because the link is basically overriding whatever comes from the other sources. So we have two problems, which can be really easily fixed. What I have to do is first to delete this classic link. Okay, so go here, delete links. Then let's fix the point first, just so have we clear situation. And now instead of using this output, now I'm going to link mark the set point. So my data point. And on the Modbus point, I'm also going to use the link from set point. But now instead of using those output and inputs, I'm going to use the reference. So this is a special linking method, which is going to basically solve those two problems which I showed you occurred during normal link. So now let's try to, okay, first there is a little configuration that I need to do in the Modbus point. Here in the input priority, I need to select the priority of the data point that the data should basically be connected to. So the input number 16. Okay, so now we have to fix the point. We have 20, we have 0, so I need to. Now the register looks okay, status is okay. However, I would like to cause it to go into the down status. So I need to put here 50,000. So now we have status down, and it is resembled also in the application. So as you can see, not only the value comes from the link, but also the status of the communication point. So just by looking at your application, you can immediately see that there are some communication issues that you can troubleshoot and just identify right away. So let's just go here with the 1500s and try to change it from the Modbus. So the same scenario, 27, let's say. Value is changed through the Modbus. It's going back. Of course, it's synchronized with my data point, but also it is, if we take a look at the Modbus point now on the right-hand side, you can see that it's also synchronized back all the way back to the Modbus point. So basically, the data can be synchronized in both ways. It flows not only from the destination to the target, but it's synchronized back from the target to the destination. So in such cases, when you have a data point and multiple sources of the information that want to change this data point, if you change in one place, all the others will be synchronized as well. So this is really easy and cool feature. Okay, so this is about the networks, about how to efficiently connect network data with the application data. Just a few words about the system. So as Marcin previously mentioned, we just have one connection to do everything associated with the device. Not only with the integration of the data point, not only with the application creation, but also with management of the hardware settings, creation backup, and everything else. So here we have logs, for example, which you can decide what kind of logs you want to read and log from your system, basically, and then maybe troubleshoot those. We have backups. So if you take a closer look, we have backups on device. So first you can create an on-device backup, but then you can also copy this backup to your local PC to be sure that you have some additional security. And then we also have the platform where we decide, we can see what is the performance of our hardware, and we can decide maybe that we want to set the time. There is a possibility to use just a hand mode to set UTS time, but also you have possibility to use the network time protocol to connect to some time servers, which could provide time for you. I didn't mention about the licensing, sorry, the limitations of the system. So what is the limiting factor of what you can do, basically? So actually, normally we would think that how many points you can integrate using the networks is the limiting factor, but not in this case. So basically, it doesn't matter how many network points you are going to have using the Modbus or BACnet. What matters for the limitation for that is number of data points that you have. So in this case, I have 1, 2, 3, and 4 data points that I created, and this is all I need to care about. The limitation is 150.
In the case of rack 18.
Yes, of this controller. Of this controller is 150. Yeah.
And I think this is very important to add that we don't have a license file. It's fixed and it cannot be changed. So it's not something like we can buy, extend it. It's fixed during the manufacture process. You can easily check this under the system. Yeah, I don't know if you got time to show it. I know we are running out of the time probably. So
yeah, so
but
here
you can easily check it. Yeah, so it's sorry 200. Yeah,
Yeah. It's only a special version.
the special version is
Special version of Tobias
Okay,
controller.
150 is
150
license here for this particular controller.
yeah. So that will be it about what we have in store now. But we will go to the next part. I think Tomasz right now can show something about it.
Yes, and now we can back what we will have in the future. So it's not the end of the technical part because we want to present the planned scope of the future functionalities, mainly in 2024, will be officially released. From functional point of view, we will have some more extension of the data points. So we will have the trends and alarms, which allows you to collect the data and notificate on back network. To easily integrate third-party devices, we also have the backend discover functionality. We will make some small improvements to the components in the application and add the multi-user level. So those kind of scope will be in Nano Edge Engine. From tool point of view, we will have the multi-device manager, and the custom configuration features allows you to manage many devices in the same time, make a quick restore of your application, quick deploy for many devices. And now we also come back to today's technical webinar topics. So we will show you the web and haystack, how it looks like, the software development kit, because as you remember from the beginning, Nano Edge Engine is built in a modular way. And
it's C# technology.
And it's the C# technology allows customers, deeply programmers to make their own library. And we will show you the possibility to program the devices from the Niagara workbench. So let's come back to the live video.
Yep, I'm just going to share my screen again.
In the meantime, I think it's worth as well go back to this license. We decide to license a data point, not the network point, because today the values in the data integration is something which today is a standard, and we believe that the data which you want to expose to the external world is a value. That's why we try to make it simple as well. So as far as you not expose the data from the network, then you can have basically as many network points as you want, But if you're gonna try to utilize those data in the logic or expose the data, then you have to go through the data points. And this is the license based on the data. It's a little bit different model than we have it in Mac, for example, or JS.
Yeah. Okay, so Tomasz mentioned about 4 additional features. So I will start with those that I have already created base for. So I mentioned that Haystack is going to be powering additional functionalities. So web page is one of them. So to see how it works, I can just go to the web browser and type in the IP address of my controller. So basically, this is my IP address and click OK. So this is what you actually get without doing anything special. So this you get right out of the box using the equipment. So the tree on the left-hand side resembles everything that you create in the IC tool. So I've created 2 equipments, lighting zone, room central, and below FCU1, FCU2. So for the lighting zone, there is no point. So that's why there is information that nothing was found. And for the room control, we have data that is associated with the particular equipments. So we have room control, like a summary of all the equipments below, but also we can go to the specific equipments like FCU1, and you see the data inside. Of course, those points, which you can see here, are also active, so you can type the value, and it will be changed in our system everywhere. So 30 is here. If I take a look into the Modbus, 30 is here as well. So those values are synchronized in each and every way. Okay, so this is how it looks like. Basically, still, and another thing that probably works almost out of the box. So I didn't have to do anything. All I had to do is to just create equipments, and that's it.
So as we're gonna develop the application, this user interface will be automatically built together with the application.
Yeah.
Without an extra human effort.
Yes, exactly. So that's the main power of the Haystack and the equipment. And the Haystack, just a simple example, can be used to pull the data from the device. So in this case, when I'm in the web browser, I can go with the slash and write the Haystack. Haystack, then again backslash, and then go for read. And the read allows me to read the data from the device. I need to apply the filtering. So I need to apply the query. Then I go with the filter, and here I filter the points based on the tagging information. So the default tag that is allowed and that is added to every data point is called point. So as a result, I will see information about every data point that I have inside my application. Here we have columns of the data, and here we have some information.
So basically what the system does underneath, it actually create a haystack structure.
Yeah.
So that's why we do recommend, instead of using folders, we do recommend using equipments, because as you cannot see here probably, there's another request. I think if you go to Haystack now, it will show you as well all the equipments. And then those equipment are the only components which are equipment components, not the folders components. The same is with the web graphic interface, which builds based on the equipment. So basically, what the Nano Edge engine is today is Modbus backend, but it's going to be very soon available with the Haystack tags and together with the auto building or generation graphic without an extra effort. Same with the Haystack, correct?
Yeah. So yeah, this is like the point, standard point, of course. If we take a look, investigate a little bit further, this particular point, we have a tags field, a tab, where here we have some additional tagging data. If you're not happy with it, you can add it, and you can add something more. Let's say the temperature tag, which can be added manually, and then it can be used to filter our data here. Yeah, just like that. Just by applying this change, I can just filter the data and see just one particular point. So the one more thing which I would like to show you is I think it was fourth thing in the list. It was any tool link. So it allows you to program basically your application. Instead of using IC tool, you can use also the Niagara workplace. So you can do everything with the nano engine from here. So this is like an add-on, additional module which you can add to Niagara. So all I had to do, I can go to my .NET Network Array C18. And here I have a special palette, which is called ISMA Nano, which I can add. Inside, we have a programming folder, inside of which we have nano program extension. This needs to be added into the Array C18. I'm going to go to the IX property sheet. So here, what I need to do is to right-click on the nano program extension and invoke the action connect. So basically, we need to put here the credentials that I'm using to log into my device using the IC tool. So the port number 88, username, and password. And connection failed. Probably I put the wrong password.
Like always.
Like always. Yeah, loading schema. So now it should be good. So now it was loading schema and it is ready. So now if you take a look.
And I think it's worth to add that this is what I explained at the very beginning, that the device is gonna give it to us. I mean, in that case, into the Niagara workbench, all the modules, all the components necessary to work with this.
Yes.
This nano connector it doesn't include the libraries, only includes the extra module for connectivity.
Yes, exactly. As Martin said, you can see in the libraries exactly the list of all the elements that are needed for programming using Niagara. So if I take a look at the library core, we have binary data point, which can be used to create a new binary data point directly from Niagara. We don't have to go to the IC tool. We can do everything here.
So the only thing we needed is this ISMA Nano programming extension, and that's all we need. And we can connect with any nano changing devices, because all the rest will be received from the nano during the connection process.
So the loading schema process was the process to load all the necessary files.
And I don't know if you noticed, that was extremely fast. It's not like a few minutes, it's a few seconds.
Yes, exactly.
And probably you didn't see this because it was also just takes less than 1 second. It was the loading tree.
Yeah.
Yeah, it has loaded the tree that you can see now. It basically is everything that is inside the IC tool is visible through here. So I have my applications container, my HVAC equipment, room control, and FCU, and everything is here.
So the tree is the same as we have it in IC tool, correct?
Yeah.
And if we change something here, we're gonna see those changes in the.
I can change from here, and it should be visible through here as well. But this is actually set from Modbus, so probably it will be better to use this one. 37, I change from here, and there is also a change.
And if you move the thermostat component,
it's also moved.
It's moving.
And we can also see the value of the space temp on the web browser. Can you show it?
Yeah.
Let's check.
Yeah, of course. So
basically, this what you just showed, guys. It shows that we can work more than one person at the same time, because we work from Workbench and from IC tool at the same time.
Yeah, so basically that's it from me. That's from my side. So thank you very much for your attention. And now I think Tomasz has one more thing to show.
Yes, so we promise you to show the software development kit at the beginning as a future functionality. So what is really unique for the software development kit and the Nano Edge engine? We talked a lot about that the Nano Edge engine is built in a modular way. And modular means that it's got libraries. I probably said this twice today. So I'm connected to the second devices, real devices. We have it on our desk. And you can see that I've got one more additional library. It's the DALI library. So this is the special library write in C language using the framework SDK, which is the part of the operating system, and it's installed on the device. And when we can see what's inside this library, it's the library made by our engineers in the company. So it's the special components that you can use, for example, for lighting, to ensure the, let's say, really complex programming and requirements.
So basically, we're going to release the SDK for all those users which are much more programmers. I mean, they can extend the functionality of Nano using a standard C# language, correct? And then once they develop the extra library, they can share with, I don't know, other people, or if they don't want to do it, then by just installing the new library, we're gonna have a possibility to extend functionality of the Nano engine devices. And this is fully independent. I think you're gonna show the future of the devices as well.
Yes.
Coming. So basically, one development, it means this development will be available on different type of controllers or devices.
Exactly. So as a device, the next step of our job is to release the next devices with Nano engine. So we will have the unitary application controller, which can be compared with our well-known RAC20 based on Sedona. We will have something new. So finally, we will have the VAV controllers with the actuator and pressure sensor in one devices, and we will have the smart actuator to control our valves. So those all new devices with the Nano engine, and this
Coming soon.
This coming soon. This can be programmed from the same device, from the same tool, and this will be available soon.
Nano engine is a platform not only for RAC 18. RAC 18 is the first device released by ISMA Controlli, but there will be more and more in the very near future of devices using the same technology. The good thing about it is because it's a hardware independent, it's portable, so you can basically copy the components or copy the whole application, or even do the backup and restore in other devices. Of course, there might be some differentiation with link with the hardware specification. So everything which will not be supported by physical hardware, it will be just involved from the Nano engine. But the way the system is designed, you don't have to do any adaptation for run this application in other controller. The only thing you have to do is if you want to, I don't know, add extra features like extra protocol, extra interface and so on. But basically, if as far as we do support the same number of inputs and outputs used in the application running on RAC 18, tomorrow we can just put this application even in the smart actuator. The smart actuator became very powerful. Same with the VAV and UAC. One common platform for microcontroller devices. This is very important because we are in the world of embedded microcontroller devices.
Exactly. And just to summarize all the information which we present today, I want to invite you for the www.nee.tech page. There is a dedicated web browser page to show all the features of the Nano engine. You can get information about the key features, about the structure, about the libraries, and about the future products. So I strongly invite you to visit this page. And if you were looking for more information about the trainings, documentation, software, or maybe some example, you can open this last part of the PowerPoint presentation, which we are going to share with you. So you will find the e-learning course, you will find the links to the documentation and to the support of the manuals. You can download the software, which is free of charge. So our IC tool is free of charge. You don't have to pay for any money for this. and you can download the universal FCU application and restore it and check how our programming engineers do some small programming using the IC tooling Nano Engine.
Yeah, I think it's worth to go for the training, our e-learning platform, because this is, we have a limited amount of time. We are already, I think, 11 minutes above the time. But if you want to find out more, please go to the e-learning, and then you can find out all the nice features, because, during the 1 hour, we are not able to show everything. I think that's all, yeah?
Yeah, that's all.
We hope you enjoy it, and you have better picture of now what is Nano Engine, why we develop it, and what is coming in the very near future.
So thank you very much.
Exactly. Thank you for a lot of questions and for the participation. And see you on the next webinar.
Yeah,
Thank you.
thank you very much.
Bye.
Bye.